Hello, Data School Insiders. As you probably know, I released a video of my top 25 PANDAS tricks. There were many more tricks that I wanted to include, but ultimately I limited it to 25 to make sure that the video wasn't super long. However, I still wanted to share with all of you the tricks that didn't make it into the final video. Here they are. We'll start by importing pandas and NumPy and loading some data sets. Now let's get going. Trick number 1, check for equality. Let's create an example data frame. Do you ever have two data frame columns that look similar and you want to know if they are actually identical? Now this is not a reliable method for checking. You would think that that would return 3 true values, but it actually returns false anytime there is a missing value. Instead, you can check for equality using the equals method. Similarly, this is how you would check if two data frames are identical. We made a copy of df, and then we used the DataFrame equals method. Trick number 2, check for equality alternative. Let's create another example data frame. It's important to note that the equals method, shown in the first trick, requires identical data types in order to return true. This returned false because C is an integer and D is a float. For more flexibility in how the equality checking is done, use the assert series equal function. The assertion passed, thus no error was raised because we specified that the data type can be ignored. As well, you can check whether values are approximately equal rather than identical. The assertion passed even though D and E have slightly different values. For checking data frames, there's a similar function called assert frame equal. Thanks to Sushant Gandhi for this trick. Trick number 3, use NumPy without importing NumPy. Although Pandas is mostly a superset of NumPy's functionality, there are occasions on which you still have to import NumPy. One example is if you want to create a data frame of random values. However, it turns out that you can actually access all of NumPy's functionality from within Pandas simply by typing pd.np. before the NumPy function name. To be clear, this would have worked even if we had not explicitly imported NumPy at the start of the notebook. This could also be used to set a value as missing. That being said, I would still recommend following the convention of import NumPy as np rather than using pd.np, since that convention is so widespread. Trick number 4, calculate memory usage. Here's a data frame of UFO sightings. You can calculate the memory used by the entire data frame. You can also calculate memory used by each column in bytes. This information might help you to decide how to optimize your data frame storage. Trick number 5, count the number of words in a column. Let's count the values in this column from the UFO data frame. Notice that many of the entries have multiple colors. What if all we cared about was the number of colors and not the colors themselves? We can count the colors by using a string method to count the number of spaces and then add 1. Trick number 6, convert one set of values to another. Using the Titanic dataset as an example, I'm going to highlight 3 different ways that you can convert one set of values to another. Let's start with the sex column. There are two different values in this column. If you need to convert these values to 0 and 1, you can use the map method and pass it a dictionary specifying how you want to map the values. As we specified, male has become 0 and female has become 1. Next, let's look at the embarked column. There are three different values in this column: S, C, and Q. If you need to convert them to 0, 1, and 2, you could use the map method, but the factorize method is even easier. Factorize returns a tuple in which the first element contains the new values, which is why I had to use bracket 0 to extract the values. You can see that S has become 0, C has become 1, and Q has become 2. It chose that mapping based on the order in which the values appear in the series, and if you need to reference the mapping, it's stored in the second value in the tuple. Finally, let's look at the SIB-SP column. Let's say that you needed to keep the zeros as is and convert all other values to 1. You can express this as a condition SIB-SP is greater than 0, which will return a Boolean series that you can convert to integers using the asType method. Notice that the only value greater than 1 has been converted to a 1. Trick number 7, convert continuous data into categorical data, alternative. In the main tricks video, I used the cut function to convert the age column from continuous to categorical data. When using cut, we had to choose the edges of each bin. But if you want Pandas to choose the bin edges for you, you can use the qcut function instead. We told qcut to create 3 bins, and it chose bin edges that would result in bins of approximately equal size. As you can see, the 3 bins are ages 0 to 23, 23 to 34, and 34 to 80, and they all contain roughly the same number of observations. Thanks to Rajesh Kotkar and Aristoteles Papadopoulos for this trick. Trick number 8, create a cross-tabulation. Sometimes you just want to count the number of observations in each category. If you're interested in a single column, you would use the value counts method. But if you want to count the number of observations that appear in each combination of categories, you would use the cross-tab function. Just like a pivot table, you can include row and column totals by setting margins equal true. In fact, you can actually create the same table using the pivot table method with count as the aggregation function. Trick number 9, create a datetime column from multiple columns. Let's create an example DataFrame. You can create a new datetime column simply by passing the relevant columns to pd.toDatetime. The new date column has a datetime data type. Keep in mind that you must include month, day, and year columns at a minimum, but you can also include hour, minute, and second. Trick number 10, resample a datetime column. Let's take a look at the stocks data set. What if you wanted to calculate the mean closing price by day across all stocks? Use the resample method. You can think of resampling as a group by for datetime data And in fact, the structure of the command looks very similar to a group by. D specifies that the resampling frequency should be daily, and the on parameter specifies the column on which we are resampling. If the datetime column is the index, you can skip the on parameter. For example, let's give the UFO data frame a datetime index. Now we can use resample, and it will automatically resample based on the index. That's the count of the number of UFO sightings by year. We can calculate the count by month by changing the resampling frequency from Y to M. The string that you pass to resample is known as the offset alias, and PANDAS supports many offset aliases other than just D, M, and Y. Trick number 11, read and write from compressed files. When you want to save a data frame to a CSV file, you use the toCSV method. However, you can actually compress the CSV file as well. By using one of these file extensions, PANDAS infers the type of compression you want it to use. You can use a shell command to see all of the files we've created. You can see that all of the compressed files are significantly smaller than the uncompressed CSV file. Finally, you can actually read directly from a compressed file using read CSV. And we can confirm that the new UFO data frame is equivalent to the original UFO data frame. Trick number 12, fill missing values using interpolation. Let's create an example time series data frame with some missing values. If appropriate, you can fill the missing values using interpolation. This uses linear interpolation by default, though other methods are supported. Thanks to Vivek Gupta for this trick. Trick number 13, check for duplicate merge keys. Let's create two example data frames. We want to merge these data frames. What if we wanted to confirm that the merge keys, color in this case, are unique in the left data set? We would use one-to-many validation. It did the merge and validated that the values of color in the left data set are unique. What if we wanted to confirm that the merge keys are unique in the right data set? We would use many-to-one validation. This resulted in an error because the values of color in the right data set are not unique. Thanks to John Sandall for this trick. Trick number 14, transpose a wide data frame. Let's create an example data frame with 200 rows and 25 columns. If you wanted to get a sense of the data by examining the head, you wouldn't see all of the columns due to the default display options. The easiest solution is just to transpose the head. Since the columns have become the rows and vice versa, we can now easily browse through the data frame's head. Transposing is also helpful when using the describe method on a wide data frame. Thanks to Alex Freeman and Sandeep Pawar for this trick. Trick number 15, create an example data frame alternative. These are the methods that I taught in the main tricks video for creating example data frames. If you want an even simpler method, you can use make DataFrame to create a 30 by 4 data frame filled with random values. Make missing data frame is similar, except that some of the values are missing. Make time data frame is similar, except it creates a datetime index. Finally, make mixed data frame creates this exact 5 by 4 data frame. It has 2 float columns, 1 object column, and 1 datetime column. There are many other similar functions that you can use. However, keep in mind that most of these have no arguments and no docstring, and none of them are listed in the PANDAS documentation. Trick number 16, identify rows that are missing from a data frame. Let's create a small example data frame. Then, let's create a copy of that data frame in which rows 2 and 3 are missing. What if we needed to identify which rows are missing from the second data frame? The easiest way to do this would be to merge the 2 data frames using a left join and set indicator equals true. This adds a column to the data frame, which shows the source of each row. In order to locate the rows that were missing from DF2, we simply filter DF3 to show the rows that were only present in the left data frame. Now we can see that rows 2 and 3 were the missing rows. Trick number 17, use query to avoid intermediate variables. Let's take another look at the stocks data frame. If you wanted to filter the data frame to only show rows in which the symbol is AAPL, this is the usual approach. However, this can also be done using the query method. There are 3 things worth noting about the query method. 1, you don't have to repeat the name of the data frame within the query string. Number 2, the entire condition is expressed as a string, thus you lose any syntax highlighting. And 3, since there is a string within the condition, you have to use single quotes with the inner string and double quotes with the outer string. Let's look at another example that shows the real usefulness of query. First, let's group by symbol and then take the mean of all numeric columns. What if I wanted to filter this data frame to only show rows in which close is less than 100? The usual approach would be to create a temporary data frame and then filter that. But query works even better in this situation since you can avoid creating an intermediate object. In fact, query is a great solution to our previous trick because it would have allowed us to filter the merged data frame without creating the DF3 object. Trick number 18, reshape a data frame from wide format to long format. Let's create another example data frame. Let's pretend that a manufacturing company has 3 locations: a factory, a warehouse, and a retail store. They've created the data frame here, which shows the distance between every US zip code and that particular location. Let's create one more data frame. This is a data frame of users. It shows the user's zip code and the location they would like to visit. We want to add a 4th column to users, which shows the distance between that user and the location they want to visit. This information is available in the distances data frame, but how do we get it into the user's data frame? We actually need to merge the data frames, but the problem is that the distances data frame doesn't have the right columns for merging. The solution is to reshape it using the melt method. We've reshaped the distances data frame from wide format, meaning lots of columns, to long format, meaning lots of rows. It contains the same data as before, but it's now structured that it can be easily merged with the user's data frame. If you're ever confused about wide versus long data, the easiest way to recognize a wide format data frame is that it doesn't tell you what you're looking at. For example, it doesn't tell me what these numbers represent, and it doesn't tell me what these column names represent. In contrast, the long format data frame tells you that the numbers represent distance and these names represent location types. Trick number 19, reverse row order alternative. You might remember the drinks data frame from the main video. This is the method that I taught in the main video for reversing row order because it will always work. Alternatively, you can use Python's built-in reversed function to reverse the index and then use that to re-index the data frame. If you decide to use this alternative method, be aware that it will fail if the data frame has duplicate values in the index. To demonstrate this, let's give the stocks data frame a non-unique index. Since the index above is not unique, this results in an error. Trick number 20, reverse column order alternative. This is the method I taught in the main video for reversing column order because it will always work. Alternatively, you can use Python's built-in reversed function to reverse the columns attribute and then pass that as a filter to the data frame. If you decide to use this alternative method, be aware that it will fail if the data frame has duplicate column names. To demonstrate this, let's rename two of the columns in the stocks data frame. Since the column names are not unique, you will get multiple copies of those columns. Trick number 21, split a string into multiple columns alternative. Here's an example data frame. This is the method that I taught in the main video for splitting the name string into multiple columns. Now here's an alternative method that also works. Here's how the alternative method works. First, stir.split splits on a space character and returns a series of two lists. Then you unpack the series using the asterisk and zip the lists back together using the zip function. The first, middle, and last names are now paired together as tuples. These tuples become three new data frame columns through multiple assignment. Thanks to Daniel Chen and Prayson Daniel for this trick. All right, I hope you enjoyed these bonus tricks. Let me know if you have any questions, and thank you as always. I truly appreciate your support.